Hi everyone, so we're going to be starting a new unit starting today. So we're going to start unit 2, and that's going to really be talking about this relationship between the Earth, Sun, and the Moon. So the two things that we're going to focus on today is our Sun and Moon, and we'll get into that Earth connection afterwards. So if we continue here talking about the Sun first. So our sun has been personified in many different mythologies, so it's became a really important role here. And so the Greek called it Helos, and the Romans called it Sol. So that's just some of the different names. Some of the key features that we're going to talk about here is this photosphere and sunspots. So keep those words in the back of your head here. So how big, how powerful is their sun? So we can fit 1.3 million Earths inside of our sun. So it just gives you the magnitude and size of the sun itself. And it's the center of the universe, of our solar system. So it's going to be a really important feature. And just so you know, the sun in our solar system contains 99.8% of all the total mass in our solar system. So that's all the planets combined is only accounts for 0.2% of our solar system. So it just gives you a really big perspective of how effective it is here. So our sun has an 11-year cycle, and we're going to talk about the max activity and the min activity, and then it switches and goes back. So at our max activity here, the sun will emit higher amounts of UV radiation. So that's the radiation that people talk about, and you hear our ozone layer is not protecting us from these UV radiation. So that's kind of what we're thinking about here, what you can get a sunburn from. And that's going to equate to more ozone and warmer temperatures on the Earth. So that photosphere on the surface of the sun has a really high temperature, and that temperature is 5,800 Kelvin. So Kelvin is probably a unit that you've never heard of before. So it's just to calculate it, you actually have to add a larger number to a Fahrenheit degree. So it just gives you a better idea of how hot the sun actually is. Our sunspots over here are actually colder regions on the sun, and those temperatures usually equate to about 3,800 Kelvin. So energy from the sun is a really, really important topic that we're going to be talking about because everything is powered from the sun on the Earth. Everything. So from heating structures, even creating solar power type things. Plants use the sun to create oxygen. It warms the ocean. It really does. It warms the planet itself, and it really has this huge effect. So we're really going to use the sun as this driving force on Earth. So it drives water cycle and biochemical cycles, and when it can be harnessed to with different technologies, so solar heating, solar thermal energy, solar architecture, just a couple of examples. There's also artificial photosynthesis. So it's a really important, this energy from the sun, because it really powers everything on Earth and in the solar system in general. Talk a little bit about the effects of latitude. So we got to remember that the Earth is on an axis. So this axis leans the Earth at about 23.5 degrees rather than having us straight up and down. So this latitude is measured from the distance from the equator right here. So when we go up or down in a region, it depends on how much sunlight that we're going to see here. So at that equator region, this tropical region, we're going to have the most direct sunlight, which is why those areas are very warm. Where in less direct sunlight, we have a temperate atmosphere and temperature wise, and those are going to be where we are right now. But there are also polar regions here, and those are going to get the least amount of direct sunlight. So in general, the further away from the equator we are, the cooler the temperatures are going to be. And because of this tilt, that's why we're going to get those seasonal changes, because the sunlight is striking the earth at different angles here. So at different high and low latitudes, we have our vertical rays are hitting pretty much directly, and then those oblique rays are hitting it kind of off center, which is causing it to be a cooler temperature at those oblique rays. So if we're talking about some different seasonal changes in our climate, so they result from the tilt of that Earth's axis. So that tilt of the Earth's axis, so it's going to be really important. And that's a different plane depending on where we are in orbit around the sun. So because of this tilt, the angle of the sun rays strike the Earth, and it changes as we move around the sun. So when we're talking about our relation to the sun, it's when we are moving around the sun, and that tilt changes the angles of those sun rays. So when we're thinking about it, when we look over here, this is the United States right in this corner right here, we're tilting kind of away from the sun at this point. So at this point, this would be our winter. If we look here, we're getting some different ray of sunlight out here, and this would make it our fall temperatures. Looking here, we're pointing towards the sun in our northern hemisphere, so this is our summer. And up here, we have our spring. So the spring and the fall are kind of in between, because we are still pointing in different directions, but it's kind of an equal amount in the spring and the fall here. So in the summer, in our northern hemisphere, we tilt towards the sun, which receives more direct sunlight. There's more hours of daylight in the summer, and therefore the amount of time available to the sun, the warmer the earth is. That's why we have higher temperatures in our summer. But our winter in the northern hemisphere, we're tilting away from the sun, so it receives less direct sunlight, resulting in a lower temperature. This is kind of switched if we are in the southern hemisphere. So say if we were in Australia, so when we are having summer in America, Australia is actually having winter because the southern hemisphere is pointing away from the sun. So we're going to talk about these different seasonal changes in the tilt of the earth and how it affects different areas on the earth as well. So we're going to move on to the moon. So moon, again, is in many mythologies that we are going to talk about, or you'll hear about. And some of the names that it's been called is Luna, Selene, Archimedes, and those are just different names that you might hear the moon be called. But the moon really has a huge impact on our tides. So it really has a huge impact on the ocean. So at high tide, we're talking about our tidal bulge with the attraction to the moon. So our gravitational attraction to the moon is when we're going to have high tide. Our low tide is going to be when the moon is not there. So remember that the Earth orbits around the sun, but our moon orbits around the Earth. So at different times of the day, our gravitation to the moon is going to be different. So that's going to change our tides here, depending on where the moon is in relation to us. So I'm sure you've heard those terms before, high tide and low tide. And you can see some really drastic changes here in this photos from Canada. So here we can see a high tide. And you can see that water is really holding the boat up here. But in low tide, it goes out so far that the boat is sitting right down on the dirt. So you can really see those drastic changes in how those bulges, those tidal bulges, depending on the moon's gravity, really affects um, how the water is going to change on Earth. Okay, so we're really going to get to all the videos that you saw linked to in these PowerPoints while we're in class or either through Edpuzzle. So make sure we're paying attention to those, and I will see you soon.